Hi, in this video we will review some basic rules of differentiation and we will do some examples for those rules. Let us start with the first one. It's called the constant derivative. The derivative of any constant is 0. C is constant. Any constant, any number. Then the second rule is power rule. It says what is the derivative of x to the power n, and this is a simple rule. N comes up front, x to the power n 1 less than the original one. So n here is any real number, not just integer numbers. Everything will work that way. Then the third rule is, here we call it the constant multiple, and if a function f is differentiable and you multiply it by a constant c, then it is again a differentiable function, and the derivative of cf is cf prime of x. C is constant. Then the fourth one is sum or difference rule. Two differentiable functions, if you add them, the derivative, it's going to be differentiable, and the derivative is sums of the derivatives. If it is difference of two functions, then the derivative you differentiate. Well, there is one more thing that I encourage you to go through the proofs of the book for these cases. These are very interesting cases. And there's one more that I have to add here. This is derivative of the natural exponential function. The derivative of e to the power x is e to the power x. Well, it's basically the main function whose derivative is itself. Okay. Well, any multiple of this also has that property, but just keep this one. Derivative of e to the power x is e to the power x. Okay, these are the rules you have to know. This is just quick review, and then let's do some examples for these ones. Okay, I have a good list here. So find the derivative. So here, see, this is root x. Root x is the same thing as x to the power half. So we can apply the power rule, n x to the power 1 less. This is half x to the power negative half. Well, negative means that you can take it to the denominator and get rid of that negative in the power, and then that is 2 root x. Okay, and how about 1 over x? 1 over x is the same thing as x to the power negative 1, so you differentiate that, use the power rule, and n x to the power n minus 1. This is negative x to the power negative 2, and this you can take to the denominator, and that will be. These two you can keep in mind as rules of different things. So just will help you to do differentiations quicker. This is 1 over 2 root x, and the dx of 1 over x is negative 1 over x squared. How about this one? Okay, this is t, the third root of t squared. So this is t to the power 2 over 3. Again, you can use power rule. This is n t, well, this is f prime of t to the power n minus 1. This is 2 third t to the power negative 1 over 3. This goes to the denominator, and this is the third root of t. As you can see, you can do this. I'm assuming that you have worked with these rules, and this is just a quick review of these rules here. Okay, how about this one? This one, well, you see at the beginning, this is quotient of two functions, and I don't have quotient rule here. What I can do is that I can separate these guys and write them with the different denominators. So this is this. I'm not differentiating, I'm just rewriting function. This is x to the power 3 over x to the power half. This will give us x to the power 5 over 2 minus x to the power half plus 2x to the power negative half. Okay, nice. This way now you can differentiate this easily, because these are just sum or difference rule, constant multiple, and power rule. So the first one is 5 over 2 x to the power 5 over 2 minus 1 minus half x to the power half minus 1 plus constant multiple comes out, and then negative half n x to the power negative n minus 1. Well, so you can simplify. Yes, this guy is 5 x to the power 3 over 2 minus, this is 1 over 2 root x, and this guy here is minus, these two cancel each other, and then this is 1 over x to the power 3 over 2. And that's the derivative. How about this one? Gx is e to the power 3 x to the power pi. Okay, so you have to be very careful. G prime of x is difference of two things, e to the power 3 prime minus x to the power pi prime. Yes. This is, e is a number, to the power 3 is a number. This is a constant. Don't confuse it with function e to the power x. There's no x here. This is just a constant. Well, it's a number around like 10, something like that, maybe a little bit more. But it's a constant number, and then this derivative will be 0. This is x to the power pi is a constant, so this is power rule. So pi, x to the power pi minus 1. That is what we have. And then the polynomial here, f prime of t, I'll do power rule first, then constant multiple sum, then 2t to the power 1 minus 4 plus 0, and 5t4 minus 6t minus 4. Now that we are done with these, we can go one and do a little bit more, because these rules will help you to find derivative, and derivative of function at a point gives you the slope of the tangent line to the graph of that function. So here we are looking for an equation for the tangent line to the graph of this function. So remember, to write an equation, we need two things. First, a point. Point here, since x is given, the second component will be, this is the point through which the line will pass, and then this is basically 1. Let me just write 3, 1 to the power 5, 4, 2 times 1 plus 1, and that is 1 and 2. That's just the point through which the line passes. Now we need the slope. The slope of the tangent line is equal to derivative of the function at that point. Well, what is the derivative? So f prime of x is 4x to the power 3 minus 2 plus 1 plus, derivative of 1 is 0. So we have 12 x to the power 3 minus 2. So the slope is 10. when you have the point, when you have the slope, you can write y minus y1 equals to mx minus x1. In the term of the tangent line, you can write this as this one, f of 1 equals to f prime at 1 times x minus 1. Yeah, just plug in everything there. So y minus 2 equals to 10 times x minus 1, and simplify, this is 10x minus 10 plus 2 is minus 8. How about normal line? Well, normal line is a line passing through the point of that point, but it is perpendicular to the tangent line to that point. So the point again we need is the same, 0 f at 0 or y at 0. Here is 0, 3e to the power 0 minus 2, 0 cube, which gives us 0, 3 times 1 minus 0, which is 3. Slope, however, slope for the tangent line is f prime. Yes, so the slope for this guy is f prime at 0. But we know that the slope of a line which is perpendicular to another line, it will be negative 1 over the slope of that one. So in this case, the slope of the normal will be negative 1 over f prime at 0. What is f prime of x? Well, or y prime, sorry, this is same as saying that. Well, this is constant multiple. Derivative of e to the power x is e to the power x. The constant multiple and the power rule. So 3e to the power x minus 6x squared. So this will be negative 1 over 3e to the power 0 minus 6 times 0 squared. It's negative 1 over 3. This is the slope of the normal line to that. So y minus y prime. So y minus y1 equals to m times x minus x1. Here's y minus 3 equals to 1/3 x minus 0. So that gives us y equals to 1/3 of x plus 3. Okay. So these are the basic rules, and as I said before, I encourage you to go see the proofs of this in section 3.1. The proofs of these rules, specifically this guy and this guy. These are interesting things to learn, but you just need to know how to use these rules and differentiate functions.